Hey there, Dr. O here, and in this here little O video, we're going to be talking about writing a balanced ionic formula. And we're going to answer the question of why do we write sodium chloride like this, but calcium chloride like that? And why do we write magnesium oxide like this and lithium oxide like that? Well, that's what we're going to answer, starting right now. Let's say that we wanted to make an ionic compound with the sodium ion and chloride. The thing that we need to be aware of with ions is their charge. Each sodium ion brings with it a +1 charge, and each chloride brings with it a -1 charge. And if we add these two charges together, that is the +1 and the -1, we get 0. And we would basically say that we have a neutrally charged equation, one that balances, so that the positive charges and the negative charges equal to 0. That's how we know it's balanced. And with our charges balanced, we could now write the formula for the ionic compound with 1 sodium and 1 chloride. So let's try another. Let's say that we wanted to make an ionic compound with the calcium ion and the chloride. Now the thing that we need to be aware of with ions is their charge. Each calcium ion brings with it a +2 charge, and each chloride brings with it a -1. And if we add these two charges together, that is the +2 from calcium, the -1 from chloride, we're going to get +1. And we would not have a neutrally charged equation. This means that we haven't had our charges come to 0 when we add them together. And what this means is that we're going to have to do some more work to get this balanced and neutralize those charges, that is, get that math to come to 0, before we can complete the formula for our compound. Now what do we need to do in order to make that happen? Well, the obvious thing is that we need to do something to increase the number of negative charges. And believe it or not, that's actually easy to do. We can simply double the number of the chlorides. Now with 2 chlorides, each one bringing with it a -1, the overall contribution is now going to be -2. Now if we add the charges, that is the +2 from calcium and the -2 from our 2 chlorides, we get 0. And we would have that neutrally charged equation, one that when we add everything together, it comes to 0. And with our charges balanced, we can write a formula for our ionic compound with 1 calcium ion and 2 chlorides. And we let our reader know that we have 2 chlorides by writing that 2 in the subscript after the chloride. Numbers in the subscript tell us about the formula or the recipe of our compound. So let's try another one. Let's say that we wanted to make an ionic compound with a lithium ion and oxide. Now the thing that we need to be aware of with ions is their charge. Each lithium ion brings with it a +1 charge, and each oxide brings with it a -2 charge. And if we add these two charges together, the +1 from lithium and the -2 from the oxide, we get a -1. And we would not have a neutrally charged equation because it doesn't equal 0. What this means is that we're going to have to do some more work to get this balanced and neutralize those charges before we can complete the formula for our compound. Now, what do we need to do here? Well, we need to increase the number of our positive charges. And we can easily do this by doubling the number of the ions, lithium ions. And their contribution would then be a +2. Now, if we add the charges, the +2 from our 2 lithium ions and the -2 from our 1 oxide, we get 0. And we would have a neutrally charged equation, one that equals 0 when we do the math. And with our charges balanced, we can write a formula for the ionic compound with 2 lithium ions and 1 oxide. And we let our reader know that we have 2 lithium ions by writing that 2 in the subscript after the lithium. Numbers in the subscript tell us about the formula or the recipe of our compound. And in this case, we need 2 lithium ions for every 1 oxide to create that balance. So far, we've seen examples where we've simply had to double one ion to balance the charges. But what about a scenario where that's not the case? Well, let's have a look. Let's take the ions of magnesium and phosphide. Now, the thing you need to be aware of with ions is their charge. Each magnesium ion brings with it a positive 2 charge, and each phosphide brings with it a negative 3 charge. And if we add these two charges together, that is the positive 2 from the magnesium and the negative 3 from the phosphide, we get a negative 1. And we would not have a neutrally charged equation, that is one that equals 0 once we've done the math adding all the charges together. And this means that we're going to have to do some more work to get this balanced and neutralize those charges before we can complete the formula for our compound. Now, what if we try the technique that we used before and just double one of the ions? Let's say we double magnesium. Well, each magnesium ion has a positive 2 charge on it, and if we double that, that's going to give us a positive 4. And if we did nothing to the phosphide, we're still going to have that negative 3, and if we add these charges together, we're going to end up with a positive 1. And that is still not neutral, so we still have more work to do. Well, what if we double the phosphide? Now, each phosphide contributes a negative 3 charge, and if we double that, the overall contribution is going to be a negative 6 charge. Now, let's just stop right here and ask ourselves, what can we do to the magnesium ion in order to match this negative 6 that the phosphide is giving us? Well, we know 2 won't do it because if we double the magnesium, that only gives us a positive 4. But what if we had 3 of them? 3 of them allows us to triple the charge of each one bringing a positive 2 charge with it, and that overall would give us that positive 6 that we need to offset the negative 6 from our phosphide. So yeah, if we add this together, we're going to end up with 0, which is neutral, and then we can write our equation. And if we write the formula, we're going to have to put the 3 magnesiums in the subscript and the 2 phosphides in the subscript as well, to indicate their role in the recipe for this particular ion. Is there an easier way to go about balancing these ions when we've got kind of crazy charges like the 2 and the 3 and maybe something else? Well, the answer is yes. So let's see how that's done. We're going to bring in an equation and work it. So let's take the magnitude or the value of the charge on the first ion, and we're going to write it in the subscript of the second ion, and it would look like this in our formula. So we have that 2 in the subscript of our phosphide, and that 2 came from the charge on the magnesium. And then what if we were to take the magnitude of the charge on the second ion and write it in the subscript of the first ion? It would look like this. And look, that 3 from the phosphide, it ended up in the subscript of our magnesium, and the 2 from the magnesium ended up in the subscript of our phosphide. And this formula is the same one that we calculated previously. So this is pretty simple, isn't it? This is a technique that I like to call the red and blue switcheroo. And it's just that simple, and yes, it works every time. So let's take a look. So here we have the aluminum ion and oxide, and the thing that we need to be aware of with these ions is the charge. So let's fill in the bottom part right here, and if we do the math, we can see that, oh yeah, we are not neutral. Now, do we want to go through all the steps of doing the math and multiplying charges by some sort of coefficient? I know I don't. So let's do something simpler. So what are we going to do? Hey, I know. Let's do the old red and blue switcheroo. And let's bring in an equation. And if we take the magnitude of the charge on our aluminum and drop that in the subscript of our oxygen, it's going to look like that. And if we take the magnitude of the charge on our oxygen and we drop it in the subscript of our aluminum, it's going to look like that. And bam, we are done. We're done. And if you want to do the math, go ahead, prove it to yourself. But this is red and blue switcheroo. It works every time. And that's it. That's how you balance an ionic formula. Red and blue switcheroo. So work it out on your own. Some of these we didn't try, and let me know if you find a problem. If you do, write it in the comments below. If you didn't, let me know that too, and that this helped you out. So thanks for watching. Bye.